My name is Graphics. Now we want to look at another important aspect in calculus, which is integration. Now we are told to integrate the integral of x into bracket x squared plus 7 to the power of 10 dx. Dx means we are integrating with respect to what? Respect to x. So what we'll simply do here is we're going to use substitution method, right? Why? The reason is 1, because of the power. 2, if I differentiate x squared, I will be having something that is already present, which is what? X. X will give me 2x, and I already have x in the equation already. Now from here, I'll start. I'll say let u be equals to what? X squared plus what? 7. Now if you differentiate this, if I have my du over what? Dx, right? That is going to give me 2x, which I've explained earlier. Because when you have x squared and you differentiate it, the 2 will come down, you subtract 1, and that will be what? 2x. Because 7 is a constant, you're going to ignore 7. That will give you 0. Now if I take the x to this point, I'll be left with what? Du over what? 2x is equals to what? Dx. You can see I took the x here and I brought 2x down. Now from here it means that my dx is equals to du over dx. So I input my value into this. So this will now give me the integral, right, of x. Now what is x squared plus 7? X squared plus 7 is what? U. So times u, what is on top of x squared plus 7? That is 10 to the power of what? 10, right? Then multiply by dx. And what is the x? The x is what? Du over the 2x. So we have du all over what? 2x, right? Now this x will equate this x. So if I should rewrite that, I'm going to be having the integral of what? U to the power of 10 du all over what? 2, right? So if I take 2 out from this, I'm going to be having 1 all over 2 integral u to the power of 10 du, because I've taken this. There's a silent one here. If I take the 1 out, take the 2 out, I'm left with this inside. Now when you integrate, integration just simply means that I will add, this is my 1 over 2 here, right? So I'll be adding to the power, adding 1 to the power, and I'll bring the power, everything down. So that is what? Integration. You add to the power and bring everything down. Then plus what? Plus c. That is a constant. Now when you do that, my 1 all over 2 is going to give me u to the power of 11 all over what? 11. Then this will be what? Plus c. So from here, if I multiply 1 times u, 11 will give me u 11. And what is u? U is s squared plus 7. So I'll write s squared plus 7 to the power of what? To the power of 11. All over what? 2 times 11 will give us what? 22. Plus what? Plus c. So that will be my answer. Oh, good. So that is for that question. Then the next one, we're having the integral of what? 3s squared over s cubed minus 1. So question 2. Question 2, we are told to what? Let me just do it here. Question 2, Question 2. We are told to look for the integral of 3x squared all over what? S cubed minus 1 dx. So you follow similar process, which says that you represent this. You say let u be equals to what? S cubed minus 1. Then you differentiate u with respect to x. So the u over the x will give us what? 3x squared. This is a constant to ignore. Now if I take my dx to this point and I take my 3x squared here, I'm going to be having du all over 3x squared is equals to what? Dx. So if I should input this back here, let me just do it somewhere around here. If I should input this into my equation, I'll be having the integral of what? 3x squared, right, all over s cubed minus 1 is what? Is u. So I'll put the u here. Dot the x is what? The u all over what? 3x squared. Now this we equate this, we're left with 1. So we're left with the integral of 1 over u du. And whenever you integrate 1 over u or 1 over anything to give you the ln of that thing plus a constant, right? We're only adding a constant because of what? It is an indefinite integral. So if I put my u, I want to say therefore ln u. Ln u, what is u? U is what? S cubed minus 1. S cubed minus 1. Right? Plus what? Plus c. So the integral of 3s squared over s cubed minus 1 ds will give us this. So this is my answer here. So if you found this video helpful, please don't forget to click on the subscribe button. Thanks for watching.